Hi, everyone. Welcome to today's event for Python for Engineers. So if you haven't already, please fill out the QR code. You get to enter in a raffle at the very end for the chance to win a shirt. Everyone's good? Awesome. So on today's agenda, we're going to be covering what Python is in the first place, Python versus some of the languages we might be familiar with, and some of the basics of Python. And lastly, we'll cover some advanced topics as well as a lot of resources that you could potentially use to learn more. Today, we won't be able to dive really deep into Python, but we'll cover some of the major topics in Python and really why you should be learning it. So first of all, what is Python? Python is a simple, readable, and open source programming language. Open source means that it's publicly available for anyone to use and modify, which is one of the key factors in Python's popularity. What can Python do? Python can do a wide variety of tasks: web development, data analysis, machine learning, and AI, scientific computing, automation, and a lot more. It's primarily known for data analysis and its machine learning capabilities, but something I kind of want to emphasize is the fact that we can use Python in our daily lives to make our processes a lot easier. For example, when you go into the workforce, as for example, an intern or like a worker, if you find a situation that is automated, that is not automated, a more manual process, you can use Python to make that process a lot more automated and actually stand out from your coworkers. So Python has a lot of capabilities. You can do a lot of things with Python. How do you do all this? Well, simply, it's because with the help of libraries. It's not that type of library, it's those type of libraries like NumPy, Matplotlib, SciPy. Those are the familiar ones that you'll hear about often. And an analogy for Python libraries is, let's say you have a report due next week on whales, and you're not going to go in person and study these whales in the ocean. You're going to check out a book at the library, use the information that someone else with that expertise has written, and use that in your own report. A similar thing can be found from the libraries that we use in coding. Libraries are things that other people have written that makes the process of developing our programs a lot more easier. So how many of you guys have taken a MATLAB course at UCI or in general? So MATLAB is a popular language and it's taught at a lot of engineering schools, including UCI, mainly because it is primarily focused on scientific and engineering tasks, whereas Python is more general purpose. Because MATLAB is more focused on scientific and engineering tasks, it's going to be more, it might have more features than Python. However, there's one caveat that kind of makes employers move toward Python a little bit more than MATLAB sometimes. And that's because MATLAB is extremely expensive. A single license can cost thousands of dollars per year. And I believe UCI spends a couple $1 million per year just so we have MATLAB licenses. In addition, one advantage Python has over MATLAB is the fact that it's open source. This means that the community is a lot bigger, and that community is continually contributing to these third-party libraries to make Python the best language it can possibly be. So looking at MATLAB versus Python syntactically, you can see that if you go line by line, you can see that the syntax is pretty similar, almost identical. And they're both really concise languages. How many of you guys have taken a C language class at UCI? So one thing that differentiates Python from C is the fact that Python is a lot more concise, C is a lot more verbose, and C is a typed language versus Python, which is not typed. And we'll get into what that really means very soon. So let's learn some Python, some basics. So every program you write in any language, in any computer, can be boiled down to an input processing the input in somehow, and returning an output. Please take a look at this link. This is the example code that we'll actually go over and cover during this workshop. So I'll let you guys type in that link and have that available for you. Is anyone still typing this in? Everyone's good? Okay. So in Python, the primary ways you get input from the user is through the input function or by text or Excel files. We'll primarily today focus on the input function and Python's inbuilt features. So in the example code that we have, you can see that we use the input to get input from the user. We use the input function to get input from the user. And this allows you to obtain the data that you need to modify it and return an output somehow. Output allows you to utilize the new data and view that data in an easy form. One of Python's primary ways to do that is through the print function. You can do that through text files, Excel files, and other libraries allow you to output information in graph form, table form. So there's also that functionality. And in this program specifically, we just focus on the print function. The next important things about programming languages in general are types. I mentioned that Python is not a type system. That means you don't have to declare the types on the variables you create. We'll get into that very shortly, but some of the most common types that we use in Python are int, which represents integer values. It can be positive or negative. Float values, which are decimal values, positive and negative are viable. String, which are sequence of characters, which can be represented by single quotes or double quotes, as you can see. A list, which is analogous to an array in MATLAB or C. And lists can have data types of any type. So within a list, in this case, there's a list of 3 integer values, but that can be an integer value, a string value, a float value, or even another list. And then the last data type that we use pretty frequently is the dictionary. And that is basically an association of key and value pairs. So in this case, we have 2 keys, favorite food and age. And then the associated values for those 2 keys are pizza and 28 respectively. So in our example program, you can see that we have some of these data types inside of the program itself. That first box at the top is a dictionary. And within that dictionary, the keys are strings and the values are float values. And then elsewhere in the program, and even I haven't even highlighted all of it, but there are other string data types as well. Variables are extremely important to any programming language. Variables allow you to store data temporarily in a program and allows you to easily modify and mutate that data in whatever form you want. In this case, we have variables of different types. And what makes Python different from a language like C is the fact that Python, there's no set type for a variable. In C, you have to declare the type of a variable, and that type cannot change throughout the life of the program. But in Python, you can first assign a variable an integer value, or then if you decide that you want it to be a float value later on, you can assign a float value to that number. And variable names can be essentially anything you want. There are some caveat names that you cannot use, but in general, any name works. And to create a variable, you just have whatever you want to call your variable name, and then a single equal sign and the value that you want to assign to that variable. Variables can be considered containers for these values, and you can use these variables in place of the values in order to mutate them. So I just pointed arrows to all the variables that we declare in the example program. And we can see that every one of these lines start with a variable name and an equal sign. The next important factor inside of a Python program are conditional statements. I'm sure we all are familiar with conditional statements. And in Python, it's no different. The only difference might be the syntax. So in a conditional statement, we'll briefly cover what that is. In a conditional statement, you have a condition that evaluates to either true or false. If it evaluates to true, it's going to execute a body of code within that condition. Otherwise, it's going to skip that block of code and then continue the execution of the program. In Python, a conditional statement kind of looks like this. It starts with an if, and then immediately following the if, there's a condition. If that condition evaluates to true, then it's going to evaluate whatever code is tabbed under that if statement. On the left, we see that since the number is greater than 0, we're going to execute the code within that if statement. On the right side, we see what happens when the condition is false. If that's false, we skip that block of code right under the if statement, and we go to the next block of code. And in our example program, we have an if statement. There's a condition there that says currency and exchange rates. I won't go into detail on what that exactly means, but if that condition evaluates to true, then it's going to execute whatever is indented under the if statement. Otherwise, else it's going to execute this if this evaluates to false. The next important thing, but something I'm not going to go too into depth to because there's a lot of factors in it, are loops. So loops allow you to do a block of code repetitively a lot of times. There are two main type of loops in Python, for loops and while loops, and they're used for two separate reasons, but I won't go into too into depth with that. The next most important aspect of Python in any language is our functions. So functions are ways for you to organize your code, reuse your code, and allow others to use your code. And it's really understanding functions is what's going to allow you to understand libraries that you will need to do all these important tasks that you will do. There are two main things involving functions: function calls and function definitions. Function calls are primarily what you're going to be using when you install a library. Function definitions are when you want to create your own functions that you use that improve your code redundancy and improves like code readability. So function definitions start out with this keyword def. Right after you declare that keyword, Python knows that you want to declare a function. The next thing, So the next word after that is the name of your function. And that's the name you're going to be using when you call the function later on. Within the parentheses, you're going to have parameters. There can be any number of parameters that you want. And these parameters are used in the rest of your function in order to compute some calculation. The next important thing about function definitions are the return statement. This is kind of varies from, if you learn MATLAB, this is the area that kind of varies a lot from that. So when you return, what that means is wherever you've called the function, you're kind of replacing that call with whatever value is returned there. So for example, we have add 2, 4. So when you call this function, Python is going to look for a function named add and check whether there are the same number of parameters within both the call and the definition. And then it's going to associate that 2 with number 1 and that 4 with number 2. And you can kind of assume that num1 acts as 2 and num2 acts as 4, everywhere in this function when you call it. So if you execute this line, this function call, you're going to see that you get 6, and it's going to return 6, which is saved into the variable result or res. If you print this variable, you're going to see the result of that function call, which is 6. And in our example code, we have a function that we defined that converts the currency at the exchange rate. We have a return statement. So wherever the function is called, you can replace that with whatever value is returned. Can someone tell me what the difference between those two lines down there on the right are? Are you raising your hand?
Yeah. Okay. So it looks like the first one you just called the function, but the second one you store the value that the function brings into a variable.
Right. Something that is really easy to mess up initially is the fact that you call a function, but you never save the value. So in that first line, you call the function, but you never use the value, you never save the value, so you can never use the value. You've basically lost whatever return value is there. So that kind of covers a good chunk of the overall ideas of the Python programming language. One thing that I didn't get to touch on are classes, but this link right here is a link that I found that is very useful. Also, I'll send you guys the slides if you've signed up on the attendance sheet. I'll send everyone the slides. But this is a very useful resource. It kind of goes over everything I talked about much more in depth, and it lets you do practice exercises, which is the most important part to learning. Let's take a picture of that. So Python libraries for scientific/engineering applications. So once you kind of understand the basics of Python, you're kind of set to work with libraries that other people have written. And in those libraries, other people have written functions, variables that you can use in your own programs to compute your own things. So the most common libraries for data analysis and visualization are these 3 libraries, and they all have their own purpose and they're all very good at what they do. So I've attached a link at the bottom to a YouTube tutorial on really how to get involved in this. I'll send the slides as I said again. It might be a bit long. I think it's like around 10 hours, but there's a lot of information and it really needs the time if you want to learn it well. Oh, oops. So when I sent out the flyer for this event, I asked what other people want to kind of learn from this event. And one of them, someone asked that they want to learn a little bit about Arduino programming with Python. It exists. There's a library called MicroPython that lets you interface with a couple of Arduinos. But there are limitations because there's only a set number of Arduinos that are compatible with this library. But if you're looking to do microcontroller and embedded programming, Python may not be the best language for you. Someone else mentioned that they want to learn a little bit about Python GUIs. The most common GUI that's available when you download Python is tkinter. It looks pretty basic, but it's a good start if you want to learn about GUIs. There are definitely other GUI kits that you can learn, but for starting, this is pretty good. And there's a link to a YouTube tutorial on it. Sorry? GUI is a graphical user's interface. So it's basically anything that you can see visually and click buttons, type in inputs. The other common form of interfacing with a program is through command line, which is basically that black box that you sometimes see on a computer. The other one is a GUI, which is what we're most commonly used to and what we like to see generally. So Raspberry Pis, there is functionality with working with Raspberry Pis with Python. Python comes pre-installed with most Linux softwares. So if you have a Raspberry Pi, you'll likely have Python already in there. but you might have to download a specific library in order to interact with the GPIO ports on that Raspberry Pi. I think it's one of them is called rpi.gpio. And I've linked another tutorial on how to really do that. One issue that's commonly faced when dealing with Python is the fact that you have to manage libraries, you have to manage library versions, you need to manage Python versions. And sometimes you'll be faced with a situation where one version of a library is incompatible with another version, or one version is incompatible with the Python version. So this can cause a lot of headaches because when you download Python, it's kind of global on your computer. So there's something called virtual environments that kind of lets you have your Python environment inside of a box. And any library you download inside of that environment stays within that environment and doesn't affect any other things. So where do you start? I've kind of given you a decent amount of information, a lot of resources, but it's kind of difficult to find a place to start. I highly recommend you start with looking at Anaconda. It provides you a distribution of Python. It simplifies the management of all these libraries that you might want to download when you're learning Python and learning these different skills. I recommend you download Visual Studio Code, which allows you to write code in an editor that is pretty commonly used in computer science. I recommend you use ChatGPT. If you're confused about any specific topic, it can give you quick answers for general questions, but keep in mind that it may be inaccurate sometimes. And then Google, since Python is open source and there's a lot of contributors to Python, that means there's a lot of resources and a lot of questions that can be answered if you just do a simple Google search. I almost guarantee that any problem you face initially is going to be already answered through a website like Stack Overflow and Google. And then that's another link to kind of that teaches you how to get set up with Anaconda. And if any of you haven't already filled out this form, please go ahead and do that. But before I end anything, does anyone have any questions?
Do you have any recommendations or suggestions on how to learn the command lines and navigating different packages?
Yeah, so there's a lot of documentation on that on Anaconda. So Anaconda is a distribution of Python. It provides you a lot of resources. It provides you a way to add libraries, remove libraries, and create virtual environments. So I recommend downloading Anaconda and taking a look at that link right there, because this will teach you a little bit about Anaconda and some command line tools that you need. Any other questions?
So for interfacing with Arduinos, what would you recommend?
Generally, I think Arduinos work with C and those low-level languages. That's kind of like built into Arduinos because that's kind of like the purpose of those languages. There's a lot more documentation on C with Arduinos than there is with Python. So there's a lot more resources for you available if you're going to those lower level languages like C. Of course. Any other questions? All right. Hope this helped you guys a little bit. If you have any questions, I'm here until 4, so you can stop by and ask me any questions that you have.